So now we are going to plot the individual currents. Individual current, what is the current density along the y direction, z direction. Y direction is going to be the width, z direction is going to be the height. So see here, z direction you see at the center you have peak. At the center you have peak and it falls off as you move away from the center. And along the width, the current is almost uniform. Not zero actually, it is slightly above zero. The current is going to be almost uniform. Okay, so this is the current distribution. See, I again say all these functions are available in MATLAB. The dipole of, current of. So you just need to invoke those particular functions and see what you require from your end. Okay, that's what I've been saying it from the beginning. Now I'm going to place a dipole in front of a reflector. So backside of the dipole antenna, I'm going to have a reflector. The dipole antenna will radiate on both sides, but if you place a reflector, the antenna will become a single side radiating antenna. Now I'm running this portion of code. See here, on the back side of the antenna or on the front side, I am going to have a reflector. This reflector, you see, it is a plate. It is a metal plate. Okay. Interaction with the color bar. You can use the color bar and you can see what is the distribution. So where the thing is, where the antenna current density is maximum, where the antenna current density is minimum. So you can use the color bar and see what is the current distribution. So you can even work with the color bar. You can change the properties using the color bar. You can pull the mouse up or down accordingly. You can see the current distribution happening in the color bar. Over the mouse, over the color bar, the mouse will be transformed into a flat arrow. So we'll see this in the figure window. Okay, so they are saying that after you get this window with this color bar, if you change the property, you can see the different color current distribution on the antenna. So you have the command for this current off. So when you use current off, it will return a current vector Jx, Jy, and Jz. So from that, if you pick away Jy and Jz, and if you plot it using a figure window, you can see the current distribution along the antenna. Okay. And what we have done is antenna without a reflector. So if you keep a reflector in front of the dipole antenna, you can see what effect you have in terms of the parameters of the antenna. So that can be verified. Okay, so this one thing I need to show.